The topic 5 is the arc length, and the knowledge is from chapter 10.2 and also the chapter 13.3. So only one formula will be used, which is this one. The length L is equal to integral from A to B, the norm of the derivative of the vector r with respect to t, dt. And in the three-dimensional space, we can write down the formula as integral from a to b, square root of the inside is the derivative of x with respect to t square plus dy over dt square plus dz over dt square, then dt. So this topic is relatively easy. Let's take a look at several questions. So the first question is from the last year 2012 term test 1, question 5. And the question is reparameterize the vector rt, which is equal to 2 cosine t, 2 sine t, 3t, with arc length where t equal to 0 in the direction of increasing t. So let's calculate the arc length first. So by the formula of the arc length, we have st, which is equal to the integral from 0, since where t is equal to 0, and then the upper boundary is t, because it says in the direction of increasing t. Therefore, we have the integral from 0 to t. And then the inside function is the norm of derivative of vector r with respect to u, du. And then this one is actually equal to the integral 0t, and then when we calculate norm, we calculate the square root of the dx dt, dx over dt square, dy over dt square, and dz over dt square here, dt then. And after some calculation, and by some luck, we have this 4 sine t square plus 4 cosine t square. Then we know this one is equal to 4. And then plus 9, we get 13. And then eventually we have the st, which is equal to square root of 13 times t. Therefore, we have the length s is equal to square root of 13 times t, which we can conclude that t is equal to 1 over square root of 13 times s. Since we have the vector rt is equal to 2 times cosine t, 2 times sine t, and 3t, we can reparameterize the rt to rs, the vector rs, which is equal to this one. And the only difference is we substitute all the t to 1 over square root of 13s. Therefore, this question is finished. So let's take a look at this question. This one is from the 2013 summer session, term test 1, question 7. So the question is asking to compute the length of the part of the curve RT lying between 2 points, this one, point 1 and point 2. So by the formula of the arc length, if we want to know the length between 2 points, the first thing we need to do is to find what is the t representing these 2 points on this curve. Therefore, we let the curve RT equal to these 2 points, and then the point 1, we let in cosine 2t equal to 0, sine 2t equal to 1, t plus 1 equal to pi plus 4 over 4. Then after solving this system, we get t is equal to pi over 4. but actually this result is actually from the third equation here. However, this t equal to pi over 4 also satisfy the top two equations. Then similarly, we're finding the point P2, and then we assign value to the RT, and then we're getting t is equal to pi over 2. So the only thing left now is to calculate the length L. So after finding the derivative of r with respect to t, and we square each of them, and then we take the square root, then we get in the norm of the derivative of r with respect to t, and also by some luck we have this cosine sine 2t squared plus cosine 2t squared, and then we can get them to 1, and finally we're getting the result is square root of 5 times pi over 4. So we finish this question, and also we finish this topic.